in this video, I'm going to explain the concept of projectile motion. To study the projectile motion, the projectile should launch at certain angle theta with some initial velocity v0. So here the trajectory of the projectile is parabolic. So you have to see the red color line here. It looks like a parabolic trajectory. So in this video, we are going to get small information about the equation of the displacement of the projectile in x-axis and y-axis, and also we are going to get the equation for the parabolic trajectory. So first of all, we have to consider the horizontal motion. For horizontal motion, the projectile has no acceleration. Why it has no acceleration? Because its velocity in x-axis is constant. But in y-axis, we have to consider the acceleration is a free fall acceleration, but we have to consider a negative value of the g. Understand? So now, for getting the equation of the displacement of the projectile, I am going to take the second equations of motion with constant accelerations, which we studied in second chapter. So we studied three equations. What are the three equations? V, which is equal to v0 plus at. The second equation, x minus x0, which is equal to v0t plus half at square. And the third equation is v square, which is equal to v0 square plus 2 into a into x minus x0. For our today concept, I am going to use only these two equations. For getting the displacement equation, I am going to use the second equation. For getting the velocity of the projectile, I am going to use the first equations. So we start with the displacement. So here, first of all, I am going to explain for the horizontal motion. So the projectile horizontal motion. So for this horizontal motion, I am going to use the second equation, which is x minus x0, which is equal to v0t plus half at square. As we mentioned already, here the acceleration is considered to be free fall acceleration. Therefore, I am going to take a, which is equal to g. But we are just going to consider the horizontal motion. There will be no horizontal motion in the x-axis. Therefore, this part will be discarded. So then the equation will become x minus x0, which is equal to v0 multiplied by t. So here, when you just come for this horizontal motion, we have only the x component. Therefore, here this v0 we have to consider as v0 of cosine theta. So the x component is always cosine and y component is always sine. So for horizontal motion, our x component is always deal with the cosine component. So the velocity, the initial velocity multiplied by cosine component, because we already studied this concept in chapter 3 vectors. So how to find the x component? The x component, which is equal to the magnitude of the initial velocity multiplied by its cosine component. I'm just using this concept here. Clear? Multiply by the t. So therefore, in the left hand side of the equation, x minus x0, which is nothing but our displacement. If you see the diagram, our x0 is always start with the origin. Therefore, x0 and y0 from this diagram is considered to be 0. So therefore, our x0 and y0, better I can write it here, x0 and y0 is our origin part, so which is equal to 0. Therefore, this equation becomes x, which is equal to v0 cosine theta multiplied by t. So this is our equation of the displacement of the projectile in horizontal motion. Now, when you come for the vertical motion, again I'm going to deal with the same equation, but this time I'm going to frame the equation in terms of y-axis. So how your equation will become? Your equation will become y minus y0, which is equal to v0t plus half at square. As we already mentioned, here for y-axis, our acceleration, which is exactly the negative value of the free fall acceleration. Why this negative? Actually, the acceleration due to gravity has a positive value only, but here based on the graphical representation, the object is in the air, so we have to consider this is a negative of free fall acceleration. Now, when you substitute this value here, the above equation will become y minus y naught, which is equal to v naught t minus half gt square. Clear? But here our y-axis, that means the vertical motion always deals with the y component. So therefore here our v naught I have to write as y minus y naught, which is equal to v naught of y multiplied by t minus half gt square. Why I just wrote v naught of y? Because we are dealing with the y component. So how I can write this v naught of y? I can write this v naught of y as y, which is y minus y naught, which is equal to v naught sine theta multiplied by t minus half gt square. As we already mentioned, our x naught and y naught is 0. So I can rewrite this equation as y, which is equal to v naught sine theta multiplied by t minus half gt square. This is our equation of the projectile displacement in y-axis. That is nothing but our vertical motion. Now, we have to deal with the vertical, that means the velocity of the projectile in horizontal and the velocity of the projectile in vertical motion. So for studying the concept of this velocity, I have to use the first equation. These equations I am going to use for the velocity. So we start with the horizontal motion. For horizontal motion velocity, I have to write the equation v of x, because we are dealing with the horizontal motion. Therefore, the velocity of the projectile in x-axis, which is equal to v naught of x plus at. As we already mentioned, here the acceleration for x-axis is considered to be 0, so this term will go on. Therefore, you'll get v of x, which is equal to v naught of cosine theta. So this is our equation of velocity of the projectile in horizontal motion. But when you come for the vertical motion, you have the acceleration as free fall acceleration, but we have to consider that acceleration as negative of free fall. A, which is equal to negative of g, we are going to consider, and again I'm going to deal with the same equation, but this time for velocity I have to mention v of y. So v of y, which is equal to v naught of y minus at. So minus, here a is nothing but minus g, so minus gt. Now, what is the value of this v naught y? Because v naught y deals with the y component, so y component always deals with the sine theta. Therefore, v naught sine theta minus gt, which is equal to velocity in y-axis. Clear? So these four equations, what are the four equations? The first equation, the displacement of the projectile in x, the displacement of the projectile in y, the velocity of the projectile in x, and the velocity of the projectile in y. These four equations are very, very important to solve the numerical problems. Understand? Now, in the last part, I'm going to explain the equation of the parabolic trajectory. The parabolic trajectory equation is given as y, which is equal to tan theta multiplied by x minus gx square over 2 multiplied by v naught cosine theta the whole square. So this is the equation of the parabolic trajectory. But now we must know how we got this equation. This is very easy. So for getting the idea for framing this equation, we are going to deal with only two equations. What are the two equations? For getting this equation, I am going to use the x-axis displaced, that means the displacement of the projectile in x-axis and the displacement of the projectile in y-axis. I'm going to use these two equations for framing this parabolic trajectory. So let's rewrite the two equations, the main equation. What are the main equation? X, which is equal to v naught cosine theta multiplied by t, and y, which is equal to v naught sine theta multiplied by t minus half gt square. So these two equations just before we frame, am I right? So I'm just using only these two equations. So what are the two equations? The x equation, that means the horizontal motion equation, and then the vertical motion displacement equation. Now what I'm going to do, I'm going to use these two equations for framing this parabolic trajectory. I just name the first equation as the first one and the second one as the second equation. From the first equation, from equation 1, I am going to frame the equation in terms of the time parameter. So x, which is equal to v naught cosine theta multiplied by t, x, which is equal to v naught cosine theta multiplied by t, therefore t, which is equal to x over v naught cosine theta. So let's take, this is our third equation. Now what I'm going to do, I'm going to substitute this third equation in the second equation. Understand? So we substitute the second equation. Substitute equation 3 in equation 2. So what will happen? So first of all, I'm going to write our the second equation, and after that I'm going to substitute this third equation in the second. So let's rewrite our second equation, y, which is equal to v naught sine theta multiplied by t minus half gt square, and I'm going to substitute this t here. So what will happen? If you substitute the t here, this equation, the above equation becomes y, which is equal to v naught sine theta. In place of t, I'm going to substitute this equation. So what will happen? Multiply by x over v naught cosine theta minus half g multiplied by, again this time, for time I'm going to substitute this value, therefore multiply by x over v naught cosine theta the whole square. Clear? Now let's simplify this equation. So what will happen? V naught get cancelled with this v naught. So by that this will become y, which is equal to sine theta over cosine theta multiplied by x, right? And in the another part, second part, minus half g multiplied by x square over v naught cosine theta the whole square. All right, because this is whole square, so that means this square is applicable for x and this square is applicable for v naught cosine theta. Therefore this equation becomes like this. Understand? So based on the trigonometric concept, sine theta over cosine theta, which is nothing but our tan theta, therefore y, which is equal to tan theta multiplied by x minus, so in the numerator we have gx square, therefore gx square over v naught cosine theta the whole square, which is nothing but the equation for the parabolic trajectory. Clear? So let's just have a look of our equation. It's exactly same, right? So for getting the parabolic trajectory equation, we are just using the displacement of the projectile in horizontal motion and the vertical motion. If you are substituting this value of t in the second equation, you will get the equation for the parabolic trajectory. Clear? So this is our final answer. That's it. Thank you.